Hello! Yes, and welcome to our notes for section 5.4, where we're going to talk about non-square matrices and matrices with infinite solutions, and that's really going to be our focus today. In our last set of notes, we identified how to tell if matrices had infinite solutions, but now we're going to actually finish the process. So when we write infinite solutions, we're not done. We're going to have to elaborate a bit more. So I want to start by talking about non-square matrices. Non-square matrices occur whenever we have more variables than we have equations in our system. So, for example, if we have 3 variables but only 2 equations, that would be an example of a non-square matrix. And whenever this occurs, we're always going to have infinite solutions. Always. Whenever there's more variables than equations, there will be infinite solutions. Now, whenever a system of equations has infinite solutions, what can you tell us, or what do you remember about their RREF form? Well, remember that in that case, the bottom row is all zeros. Now I want you to think about this question. Is infinite solutions the same as all real numbers when talking about solutions to systems of equations? And I want you to think about that. Go ahead and pause the video thinking about that. And if you want, you can look at your notes from 5.3 as evidence. So is infinite solutions the same as all real numbers? All right, hopefully you thought about it a little bit. The answer is no, they're not the same. When something has infinite solutions, there are infinite solutions, but it doesn't mean every solution is possible. Now, you probably wrote something down here, so I don't want to write over that, but I will think of this graph here. All right, now if I tell you a system of equations is graphed like this, you're saying, okay, well, this line here represents my solutions. It's not all points are solutions. There's a very specific set of points on this line that are solutions, okay? So that's why infinite solutions represents all the solutions on this line. All real numbers would say any point here, any point in the coordinate plane works. That's not the case, all right? So infinite solutions is different than all real numbers. So let's talk about how to solve matrices with infinite solutions. First, we're going to write the augmented matrix. If it's non-square, we're going to add a row of zeros. We're going to input the matrix, convert it to RREF form. We're going to show all that work we normally did. And then we're going to write the new equations that matrix provides us. And I'll show you what that looks like. Next, we're going to set z equal to a. We're going to solve for x and y in terms of a. And then we're going to write our answer as our coordinate pair in terms of a. And you're probably wondering what that looks like. Don't worry, I will show you with these examples that we have coming up. All right, so let's look at example A. All right, so for example A, I'd start by creating the augmented matrix. So 3, 4, -1, 27, -9, 0, 5, -17, 6, -4, -4, -10. Alright, and now we're going to convert that to RREF form, which means we need our calculator. So let's go ahead and turn this on. We'll do second matrix. Go over to edit. We are doing a 3 by 4 matrix here. 3 rows, 4 columns. We have 3, 4, -1, and 27. We have -9, 0, 5, and -17. And then we have 6, -4, -4, and -10. And now to get out of that, remember second quit. Second matrix, math, go up to RREF, press enter, select the matrix that we just edited. For me, that was A. And here we go, and I'm going to hit math, frac, enter. All right, look at what we have here. So we have, oh, moving on me. 1, 0, negative 5/9, and 17/9. 0, 1, 1/6, and 16/3. And all zeros. Well, all zeros tells me what? That tells me infinite solutions. Okay? And now if we look at our steps, we are not done. We are not done. I know this is where we stopped in our last set of notes, but this is not where we are done anymore. What we're going to do is we're going to write the equations from this matrix. Alright, so looking at my top row here, this would tell me that x minus 5/9 of z equals 17/9, and y plus 1/6 of z equals 16/3. Alright, so what I'm going to do is I'm going to say I need to let z equal a. So we're saying z can be any value. We're going to find what x and y are in relation to that value of z. So all I have to do here is I'm going to rewrite these with z as a. So x minus 5/9 of a equals 17/9. Oh, that's a 9. Numbers are hard. 17/9. No! Sorry about that. And y plus 1/6 of a equals 16/3. So from here, I'm going to solve for x and y. So all I would need to do is add 5/9 a, subtract 1/6 a. So x will equal 5/9 of a plus 17/9, and y will equal negative 1/6 of a plus 16/3. And that right there is my value for x, y, and z. Z is a. So the last thing, remember this is a system. How do we write our solutions to systems? As a coordinate pair. So we would have 5/9 of a plus 17/9, comma, negative 1/6 of a plus 16/3, comma, a. And that would be our solution. Now, whenever we have infinite solutions, we always set z equal to a, so that last value will always be a. A lot of people often forget that. Remember, it's x, comma, y, comma, z, which in this case, z equals a. All right, let's try letter B. Now, letter B, notice how many variables do we have? 1, 2, 3. How many equations? Only 2. So we know right away this is going to have infinite solutions because this is a non-square system. All right, so what that means is when I write this augmented matrix, I need to add a row of zeros. So I'm going to have 1, negative 2, 5, 2, 4, 0, negative 1, 0, and then 0, 0, 0, 0. Alright, now I'm going to put that in my calculator, RREF, so second matrix, I need to edit. I can just reuse matrix A. So I have 1, negative 2, 5, and 2. Then I have 4, 0, negative 1, and 0, and then I have 0, 0, 0, 0. Excellent. So second, quit. Second matrix, math, go up to RREF. Second matrix A, close the parentheses. Alright, let's fraction this up. Math frac. Alright, so need to write the RREF form matrix. So RREF would give me 1, 0, negative 1/4, and 0, 0, 1, negative 21/8, and negative 1, and then a row of zeros. So let's write the equations that we get from this matrix. So x minus 1/4 of z equals 0, and y minus 21/8 of z equals negative 1. Well, what do we say now? Alright, we need to solve for x and y in terms of z, but we let z equal a. So I will say x minus 1/4 of a equals 0, and y minus 21/8 of A equals -1. For this one, I add 1/4. I'll find that x equals 1/4 A. For this one, add 21/8, so y equals 21/8 of A minus 1. And the last thing, of course, we know x is this, y is this, z is this. Write it as coordinate pairs. So 1/4 A, comma, 21/8 of A minus 1, comma, A. There we go. So those are solutions. The coordinate pairs are the solutions. So I can't just write infinite solutions anymore. I have to actually find the relation between x, y, and z, right? Think about on that two-dimensional, the relation was the graph. Now this is three-dimensional, so the relation's going to be a plane here where they all intersect, okay? Very, very, very good. All right. Let's try a couple more together. Let's try letter C. So again, notice we have three variables, but only two equations. Well, what does that mean? That means there's going to be infinite solutions. If there's infinite solutions, I need to add a bottom row of zeros here. So 1, -3, 2, 18, 5, -13, 12, 80, and add that bottom row of zeros. And let's RREF this and see what we get. So, second matrix. Go over to edit. I'm going to edit this 3 by 4. We have 1, -3, 2, 18. We have 5, -13, 12, and 80. And then that bottom row is all zeros already, so I can just leave that. So second quit. Second matrix. Math, RREF. Second matrix A, close the parentheses, press enter. Oh, nice, no fractions here. So 1, 0, 5, 3. 1, 0, 5. What just occurred? I have no idea what's going on. Let's go back down. 1, 0, 5, 3. 0, 1, 1, -5, and then a bottom row all of zeros, telling us infinite solutions, of course. We already knew that. We added that bottom row of zeros. So let's write the equations we got from this. So it would be x plus 5z equals 3, y plus z equals -5. Remember, here are my x's, my y's, my x's are here, my y's are here, my z's are here, my constants are there. That's how we're getting those equations. And I say let z equal a, which will give me some new equations. X plus 5a equals 3. Y plus a equals -5. Solve for x and y. X is -5a plus 3. Y is -a minus 5. And then write as a coordinate pair. So I would have -5a plus 3, comma, -a minus 5, comma, a. And there's my set of infinite solutions. So what this is saying is a can be any number, y is going to be the opposite of that number, -5, x is going to be -5 times that number, and then plus 3. Alright, let's do one more together. Let's do letter D here. So this one, 3 by 3, so 3 by 4, I guess, but we have 3 equations and 3 variables. So 3, -2, 3, 3, -4, 3, -3, -5, 3, -4, -3, 9. Alright, let's RREF this guy. So second matrix, go over to edit, matrix A again. 3, -2, 3, 3, -4, 3, -3, -5, 3, -4, -3, and 9. Beautiful. Second quit. Second matrix. Go over to math, up to RREF. Second matrix, so that's A. Close the parentheses. Oh, look at that. Alright, so we have, once again, shockingly, infinite solutions. Alright, so 1, 0, 3, negative 1, 0, 3, negative 1, 0, 1, 3, negative 3, and then that bottom row of zeros. So let's write the equations we got from this. We got x plus 3z equals negative 1, y plus 3z equals negative 3. We say let z equal a. So that means x plus 3a is negative 1, y plus 3a is negative 3. Subtract 3a from both, so x equals negative 3a minus 1, y equals negative 3a minus 3, which tells me my solutions are negative 3a minus 1, comma, negative 3a minus 3, comma, and a. Alright, there are my solutions. Alright, I would like you to go ahead and try some on your own. So why don't you go ahead and do E and F on your own. Pause the video, give it a shot, E and F, let's see how we do. Alright, hopefully we got E and F done. If not, go ahead and pause it again, finish. But let's check E and F together here once we have them done. So, we have 3 variables but 2 equations, so that tells me we have a non-square system. We're going to have to add a row of zeros to this matrix. 7 row of zeros. And then when we RREF, so second matrix, go over to edit. It's a 3 by 4. We have 2, negative 3, 1, negative 2. We have negative 4, 9, 0, and 7. And we have a row of zeros. And 0. Enter. Excellent. So second, we're going to quit out of that. Second matrix, go over to math, RREF, enter. Second matrix A. Let's see what we got here. Oh, let's math frac this guy. Alright, that bottom row is all zeros, of course. So infinite solutions. Let's write it out here. 1, 0, 3 halves, 1 half. 1, 0, 3 halves, 1 half. 0, 1, 2 thirds, 1, 2 thirds, and 1, and then 0, 0, 0, 0. Excellent. Alright, so what equations do we get from this? We get x plus 3 halves of z equals 1 half, y plus 2 thirds of z equals 1, and now we say let z equal a. There we go. Alright. So I will say x plus 3 halves of a equals 1 half, y plus 2 thirds of a equals 1. Got to get x and y all by itself, so subtract the 3 halves a, so plus 1 half there. Subtract the 2 thirds of a. And when I do that, I would get my coordinate pairs, negative 3 halves a plus 1 half, comma, negative 2 thirds, a plus 1, comma, a. B-E-A-U-T-I-F-U-L. Beautiful. Alright. There's some infinite solutions. Hopefully we already did letter F as well. I can see clearly 3 variables, 2 equations. We're going to get infinite solutions here. So I'm going to go ahead and draw this first one up here. 5, negative 12, 7. That looks like a Z. Let's try that again. 7, much better. 16, 3, negative 7, 4, and 9, and then 0, 0, 0, 0. There we go. So second matrix, go over to edit. This is a 3 by 4 matrix with 5, negative 12. Ooh, almost forgot negative. Essential that you type everything in correctly. Negative 12, very good. 7 and 16. 3, negative 7, 4, and 9. And then a bottom row of zeros. Excellent. So second matrix, math, RREF. Second matrix A, close parentheses, enter. Very nice. Okay. So we get this new, and I suppose I should try to show my work here, RREF. We get this new matrix, which is 1, 0, negative 1, negative 4, 0, negative 1, negative 4, 0, 1, negative 1, negative 3, and then a row of zeros, of course. What equations do we get from that? X minus z equals negative 4, y minus z equals negative 3. We will let z equal a. Okay, so I will rewrite this. X minus a equals negative 4. Y minus a equals negative 3. Add a to both sides, so x equals a minus 4. Y equals a minus 3. And my coordinate pair would be a minus 4, comma, a minus 3, comma, a. There we go. Beautiful. Alright, hopefully we're feeling really good about this. We got 2 more here. Let's try to knock them out. Go ahead and pause the video, try G and H on your own, and then we will check them together, okay? Go ahead and do G and H on your own, and then we will check them together. Alright, let's see how we did here. So looking at letter G, we got 3 equations, 3 variables, so we're not sure how many solutions this one will have at this point. So negative 2, negative 2, negative 3, 9. We're going to start by writing our augmented matrix. And we're going to RREF that. Need to second matrix. Go to edit. It is a 3 by 4 matrix of negative 1, negative 2, negative 1, and 7. Then negative 2, negative 2, negative 3, and 9. Then negative 2, 2, negative 5, and negative 1. Second quit. So we're going to do second matrix. Go over to math, up to RREF, press enter. Second matrix, A, close parentheses. Let's see what we get. Okay, let's go ahead and math frac this guy. We don't like decimals. So 1, I'm going to go ahead and write it down here. Oh, hello. Moving over here. So we got 1, 0, 2, negative 2. We got 0, 1, negative 1 half. Negative 5 halves. And then all zeros. So what equations do we get from that? We get x plus 2z equals negative 2. Y minus 1 half of z is negative 5 halves. And we'll say let z equal a. So x plus 2a is negative 2. Y minus 1 half of a is negative 5 halves. And z, of course, equals a. Let's solve this here. So x equals negative 2a minus 2. Y is 1 half a minus 5 halves. So my coordinate pair, negative 2a minus 2, comma, 1 half a minus 5 halves, comma, a. There we go. Alright, last one. Last one's non-square, so we know that this is going to be a matrix with a row of zeros at the bottom. So 2, 3, 3, 7, 4, 18, 15, 44. And then 0, 0, 0, 0. And we're going to RREF to see what we get. So let's put this in here. Second matrix. Go over to edit. Matrix A is 3 by 4. 2, 3, 3, 7. 4, 18, 15, 44. And then a row of zeros. 2, 3, 4. There we go. Alright, second quit. Second matrix. Go over to math, RREF, press enter. Second matrix, select matrix A, close parentheses. There we go. Ooh, let's math frac. So 1, 0, 3 eighths, negative 1 fourth. 1, 0, 3 eighths, and negative 1 fourth. 0, 1, 3 fourths, 5 halves. 0, 1, 3 fourths, 5 halves. And then that bottom row of zeros, of course, left unchanged. Infinite solutions. What equations do we have from here? We have x plus 3/8 of a equals negative 1/4. Y plus 3/4. Oh, I already said a. Let's make sure we write it as z. 3/4 of z equals 5/2. And then we say, let z equal a. So when I do that, I get x plus 3/8 of a is negative 1/4. Y plus 3/4 of a is 5/2. Solve for x and y, so x will equal negative 3/8 of a minus 1/4. Y will equal negative 3/4 of a plus 5/2. So my coordinate pair would be negative 3/8 of a minus 1/4, comma, negative 3/4 of a plus 5/2, comma, a. And there we go. There are our infinite solutions. All right, well, that's it for today. I hope you all have a good understanding of what to do now if we get infinite solutions. The key here is you can't just write infinite solutions. You have to state the relationship between x, y, and z in terms of a. All right, well, this is Mr. Carter signing off for now. I'll see you again soon.